In other videos on this YouTube channel, we've looked at using what's called Gaussian elimination to solve a system of linear equations using a matrix. And we've also used the Gauss-Jordan method to invert a 3x3 matrix. Both of these methods rely on what's called row operations. And in this video, we're just going to go into a bit more detail into explicitly what an allowable row operation is. So there are three types of row operations that are allowed. They are called sort of row switching, and that's sort of swapping one row for switching, or swapping one row for another. There is row multiplication, and that is simply scalar multiplication of one row by a non-zero constant. Okay. And that we're also allowed to do row addition, and that is adding or subtracting, it's the same thing really, just with an additive number. So adding any multiple of a different row to any row. Okay, so there are three allowable row operations, and just to say at the top, so these are the things, e.g. as used in Gaussian elimination or the Gauss-Jordan method. And often, let's have a look at a quick example. We're not going to do a full example because those other videos on Gaussian elimination or the Gauss-Jordan method, reduced row form indeed, will have fuller examples. But let's just have a quick reminder of the idea. So, e.g., often we have an augmented matrix and aim to use row operations to obtain the form. We'll look at 3x3 here. So we want a sort of 1, 1, 1 on the diagonal, and whatever we want above the diagonal, and zeros below the diagonal. And then this is going to be augmented with another column, which is something like this. So this is often a form we aim to get into. We don't always require ones on that diagonal, but this is the idea. And here's an example. We're going to start with our augmented matrix from a system of linear equations is, let's say, 0, 0, 2, 6, 4, 3, 4, 1, 2, and 24, 11, 14. Okay, now notice we want to get these zeros below that leading diagonal. So one way to start would be to switch that bottom row where there's a 2 in the first column, switch that to the top so that we have our zeros below the leading diagonal. So that would be a row switch. So row switch, so we could do, let's switch row 3, we're going to switch it with row 1. And we have to do this for the entirety of the matrix, including the augmented part. So we're going to switch row 3 and row 1. So now we get 2, 3, 2, and 14 at the top. Row 2 is unchanged, so we still get 0, 4, 1, and 11. And finally, row 3 switched with row 1, so row 1 now goes to the bottom. Okay. And we often use this sort of R notation to denote rows, and it's useful to write down the operations that we're doing just to keep track of what's happening. So that's our example of a row switch. Now, row 1, let's say we want that 1 on the leading diagonal. At the moment we have a 2. So we could half row 1 and we would end up with a 1 on the leading diagonal. And that would be an example of row multiplication. So let's do that. So we'll replace row 1, we'll replace that with half of row 1. Okay, now that 2 will turn into 1, 3 will be a 1.5, and this 2 will be a 1, and now we'll have a 7. We're not going to do anything with row 2 and row 3 at this stage. It's often easier to just do one operation at a time. 0, 4, 1, 11, 0, 6, 4, 24. Okay, so now that first column's looking pretty good in that form that we were looking to obtain. Now in the second column, we don't want a 6 at the bottom, we want a 0 at the bottom below that leading diagonal. So how can we get that 6 into a 0? Well, we can use a row addition. We couldn't do a row multiplication because we're not allowed to multiply by 0. We could do a row addition. Now notice if we add any multiple of row 1, we'll end up with we will affect column 1. So we don't want to use row 1 because we don't want to affect column 1 because column 1 looks okay. Whereas if we use row 2, because row 2 has a 0 in column 1, we can easily use row 2 without affecting column 1 at all. So what we'll do is we notice that in the second column, if we do, well, we can just see. If we replace row 3 with row 3 minus 1.5 lots of row 2. And this is a row addition. In this case, it's subtraction, but we're subtracting 1.5 times row 2 from row 3. So now row 1 is unchanged, 1, 1.5, 1, 7. Row 2 is unchanged, 0, 4, 1, 11. And now row 3, well, we take away 1.5 lots of row 2. We get 0. 1.5 times 4 is 6, so we do 6 minus 6 is 0. That's good, that's what we wanted. Then 1.5 times 1 is 1.5. 4 take away 1.5 is 2.5. And finally 24 take away 1.5 lots of 11. That's 7.5. Okay, so we're most of the way. We haven't fully finished off because we were in this example we were trying to get it in the form with 1s on the leading diagonal, but we don't actually have to go any further. Really, we could actually solve our linear system of equations from this stage. And I've achieved what I wanted in this video, which was just to show the 3 allowable row operations, that is row switching, row multiplication, and row addition.